So the best way to learn Pig is by looking at an example. And again, what we're going to do is use the Movie Lens dataset to actually find some good old movies. We want to find movies that have an average rating of more than 4 stars and are sorted by their age, by their release date. So we might be able to find some oldies but goodies that we didn't know about to go back and watch. So let's just jump right into the Pig script code that would actually do this. So let's imagine we're writing a Pig script to do this analysis. And again, remember, this is taking the place of writing a MapReduce job from scratch using mappers and reducers. So let's go through it one line at a time. So the first thing we need to do is actually load up the movie ratings data itself. And as you recall, that lives in the u.data file, which is just a big old data file full of 100,000 movie ratings, where each line consists of a user ID, a movie ID, a rating, and a timestamp. So with one line of code here, we can load that up into what we call a relation in Pig. So what we're going to do is create a new relation called ratings. And you can think of this as like a data set, basically. And that ratings relation will be equal to load, which is the function that loads data from disk. And this is a path to HDFS. So under user mariadev ml-100k u.data, we'll place that file there in our HDFS cluster, and that will load it up. And this as clause gives it a schema. So another difference between Pig and a relational database is that the actual schema is applied when you read the data in. You know, it doesn't have any sort of inherent structure or schema or types associated with it. So we can just load in plain old text data like we're doing here and use as to actually assign names and types to each individual field. Now u.data is tab delimited, and that's just what Pig expects by default, so that's cool. So what it's going to do is load in each line of u.data and split it up into 4 different fields delimited by tabs. And it's going to name the first field user ID, and it's going to cast it to an integer. And then it's going to call the second column movie ID, and that's also an integer. And it's going to call the third column rating, also an integer. And finally the rating timestamp, which is also an integer. So at this point, we end up with a relation named ratings, and it has this schema baked into it. And what we get back is a relation that has on each row what we call a tuple of information that was read in. So this is actually a series of tuples of 4 integers each that represent user IDs, movie IDs, ratings, and timestamps. Okay, so at this point, this is what the ratings relation contains. So one line of code, we loaded that up. Now this would have been normally a mapper in MapReduce, right? So we're basically very compactly and quickly writing a mapper here, and that's what it will end up doing under the hood if we actually run Pig on top of MapReduce. Now, we also want to load up the u.item file because that's what contains the mappings between movie IDs and their names. You know, this exercise wouldn't be very fun if at the end of the day it told us that movie ID 233 was the one that we wanted to watch. We actually want to know the movie name. So to do that, we also need to load up the u.item file. And u.item is a little bit different in that it has delimiters of pipe characters instead of tabs. But that's okay, we can deal with that. So just like before, we can use the load command, and we're going to create a new relation called metadata that associates data with each movie ID from the u.item file that I've installed onto HDFS under that path, using Pig storage and with a pipe character there. So this is telling that I'm using, you know, a field-based format here that's delimited by pipes instead of tabs. And as before, I can say as and give it an explicit schema to infer onto that data as it comes in. So as each line is read in, it's going to cast the first column to an integer and name it movie ID. And the second column will be a character array, which is basically the Pig version of a string. And it's going to call that movie title. And we're going to take the third column and name that release date. And for now, we're going to treat that as a character array as well. So it's in kind of this weird format of day-3 character month name dash year. And we're going to have to convert that to something more useful so we can actually sort it later on. Now, one thing that's useful when you're developing Pig scripts is the dump command. So that lets you actually dump out the contents of the entire relation. Now, obviously, you probably want to be using a subset of your data so you don't get overwhelmed with the 100K. It's not that bad, so I can just go ahead and do that. But once you do something like dump metadata, that will produce an output like this that actually gives you a little view of what's in that relation so far. So that's very useful for debugging things and making sure that you're extracting what you think you're extracting. So at the end of loading up this metadata relation, it contains these tuples of movie IDs, movie names, release dates, the video release date if it has one, which it hardly ever does, the IMDb link, and there's actually more data about genres following this in the u.item file, but we didn't bother to load that in. So anything that's not part of our explicit schema just gets discarded, and that's fine. Okay, moving on. So at this point, we have our ratings data and our metadata both loaded up. So we have ratings and the movie ID to name and release date data. Now, the next thing we need to do is actually transform that movie information, the metadata, into something that we can actually use. So remember, we want to sort things by their release date. And to do that, I need to get the release date into some sort of format that I can actually sort. So that's what this is doing. We're taking, this is just the same line we had before where we loaded up the metadata relation. And what we're going to do is use something called forEachGenerate. So this lets us generate a new relation, and then we're going to name it nameLookup from an existing relation, in this case metadata. So it's going to go through each row of metadata and generate a new row into the new nameLookup relation that contains the following stuff. And that's going to include the movie ID from the original relation, the movie title from the original relation, and then we're going to apply these datetime functions to actually transform the release date of, day, month, year using this date string here. And you can look up, what the exact syntax of this is, into a Unix timestamp. So a Unix timestamp is just seconds since January 1st, 1970. And that works out to this very large number in the case of January 1st, 1995. And we're going to name that new column release time. So that's what as release time means. So what we end up with is a new relation called nameLookup that contains a movie ID column, a movie title column, and a release time column. That's a new column that we created based on the release date of the original relation. So now we have something that's a little bit more easy to handle here. Note that we also discarded the IMDb link while we were at it because we didn't need it. So we now have a new nameLookup relation, and you can probably see where we're going with this. This is going to give us the ability to join this relation with something else to actually figure out the names of given movie IDs when we're done, and their release dates. All right, so the next thing we need to do is figure out all the ratings associated with each individual movie, because we need to figure out the average rating of each movie somehow. And that's what group by does. So we can say we're going to create a new relation called ratings by movie. It's going to be able to group ratings by movie ID. So what this does is it actually creates what's called a bag in Pig that contains tuples of all the individual rows associated with a given movie ID. Okay, so all the ratings associated with each movie ID get thrown into this bag of stuff for each individual movie ID. So that's what we end up with here when we dump that out. Now, think about what's happening under the hood here. This looks a lot like a reduce operation, doesn't it? We're doing a reduce on the movie ID and collecting all the ratings values associated with each movie ID. And in fact, that's what will be happening under the hood. But we didn't actually have to write a reducer. All we had to do was write this little one line of very intuitive code that looks a lot like SQL, sort of, right? So you can sort of get some appreciation of the power of Pig here. We've already written multiple steps of MapReduce here with just a few lines of code. Now to actually compute the ratings, the average ratings, we can do something like this, where we can say for each ratings by movie, generate. So again, we're going to go through an existing relation called ratings by movie, generate new rows, and it's going to generate a group as movie ID. And we'll talk about why it's called group in a second. And then we're going to create another column called average rating that contains the average of all the ratings that we saw. So average, AVG, will go across all the stuff in our bag and average them together. And what we end up with is something that looks like this. Now, to get a little, it's easy to lose track of what all the things are named in your different relations. So if you ever need to refresh your memory on what's actually available for you to use within these expressions, you can use the describe command to do that. So let's describe the schema of the ratings relation, and describe the schema of the ratings by movie relation, and describe the schema of the average ratings relation that we ended up with. So if you go back and look at the original ratings relation, it contains the user ID, movie ID, rating, and rating time, right? And then ratings by movie is going to be this group. So we ended up doing a group by to get this, remember, where the group is actually the movie IDs that we group by, but it ends up getting called group. So we have to deal with that. So that's why we said generate group as movie ID. It's going to go back to ratings by movie, extract the group, the column named group, and rename that as movie ID because that's what it is. Okay. And then it also contains this bag of ratings. And when we do average, we're going to say we're going to take the average of the ratings bag, and we're specifically going to take the average of the ratings field within each entry there, okay? So that's how we actually say we're going to pluck out the rating from each individual row of the ratings and average them all up for each individual movie. And we're going to name that average rating. So that's what we end up with. Our resulting relation is a movie ID and an average rating. So at this point, we have a relation that contains every movie in our database and their average rating from the entire ratings dataset. Next thing we want to do is filter things out so that all we're left with are good movies, things that are rated more than 4 stars on average. And that's very easy to do. All we have to do is say filter average ratings by average rating is greater than 4.0. And very intuitive. Don't need to talk about that, right? So that's going to give us back a new relation that contains everything that was in average rating that has an average rating greater than 4. So this is all the really good movies. Now we need to go back and join in the movie name so we can actually understand what this data means. So this gets a little bit dicey. It's actually a heck of a lot easier than trying to do it by hand in MapReduce, right? So the syntax here is just join 5-star movies, which is the resulting filtered relation we had, by movie ID. Name lookup by movie ID. So it's basically saying I want to join these two relations, 5-star movies and name lookup, by these fields that I specify. They both happen to be named movie ID, but they could be named something else. And it will look for rows that match both relations and the movie ID field. So essentially what we're doing is we're going through each row of 5-star movies, looking up the corresponding row in name lookup, and joining that data in to create a new relation called 5 stars with data. Okay, so let's take a look at what's going on here. First of all, we will do a describe on 5-star movies and name lookup. These are the two relations that we're going to join. You don't have to do that describe. It just makes it easier to understand how to write that query and what's going on. So we can see that we have a movie ID in each one, and then we can join both of those by movie ID. And what we end up with is this, and this is worth talking about. So note that we end up with these new names for each column that are basically the original relation name that it came from, : the field. So we end up with, by joining these things together, 2 movie IDs in the result. So we have the 5-star movies : movie ID and name lookup : movie ID. Even though they're the same value, they're named 2 different things. So if you wanted to, you could go through with another for each generate to actually clean that up, but why bother, right? We get the information we need here. But the important point is that when you do a join, you end up with this weird syntax on the names of the columns where you have the original relation name : and the name of the field. So we're going to use that in the next step. Last thing we need to do is order things by the release date, and then we have our answer. So to do that, we use order, and we can just say order 5 stars with data by, and remember we had to use that weird : context syntax to actually get the field name that we want. Name lookup : release time, and since we converted that to epoch seconds, that actually sorts nicely numerically, and we can just dump out the results. And that will actually give you all of the 4+ star rated movies sorted by release date, but we're just going to print out the first 4 here for the purpose of this slide. Turns out the oldest movie that had a really good rating was an old movie from 1934 called The Thin Man, and I've never seen it, but maybe I'll go try and track it down. Might be worth watching. And in fact, if you go through all this data that we end up with, there's some real gems in there. So I'm definitely going to add some of these to my Netflix queue. All right, so let's actually take a look at it all together here in one place. And you can just review our entire approach here. First, we load up the ratings relation, giving it a specific schema. We also load up the metadata from u.item using a explicit delimiter of a pipe and a given schema. We then go through the metadata and convert that to a new name lookup relation that contains a movie ID, a movie title, and the release date converted to a Unix timestamp. We then group all the ratings by movie ID, so that's basically doing a reduce to collect all the ratings together for each movie. We then go through that and compute the average rating for each movie. And then we filter that by movies that have an average rating of greater than 4. We then join in the name lookup, so we have the names associated with each given movie. And finally, we sort it by release date, and that gives us our final answer. Okay, so if you need to hit pause and stare at this a little bit, definitely worth doing. The best way, again, to learn Pig is by looking at an example like this, and this actually does illustrate a lot of the very common things you might do with Pig. So let's actually go run it. Let's see what we end up with and see how we would actually enter this in Ambari.